Hello, welcome back to Math with Patrick. It's March 23rd, and we have problem number 82 to solve together today from this calendar. And the answer is 23. As always, the answer is just going to be today's date. And when there's all these variables and no instructions, you can assume that the instruction is to solve for x. So we have two numbers, y and z, that add together to get to 41. So their sum is 41, and when they multiply together, they get 288, or their product is 288. And then finally, once I figure out what these numbers are, it looks like if I subtract the two and then take their absolute value, I should get today's date, which is 23. And I actually want to talk about this last part first, about these absolute value bars, these vertical ones here. Basically, anything that you put into absolute value bars becomes positive. So if we have the absolute value of -3, it's 3. If we have the absolute value of 2, it's still 2. And if we have the absolute value of 0, it's, 0. Another way to think about this is the distance to 0. So when I have a subtraction thing going on the inside, so let's say we have 1 minus 3, and then we take the absolute value of that. Think about doing the subtraction first before you take the absolute value. I've seen some folks make some mistakes where they just assume, let's just make everything positive and call this 4. That's not the case. That's not how these absolute value bars work. Think about doing the problem on the inside first before taking the absolute value. And what I wanted to point out is that even if you swap the terms in your subtraction problem on the inside, it doesn't really matter what direction they are. 1 minus 3 and 3 minus 1, once you take the absolute value, will give you 2 both times. And so it doesn't matter if it's a minus b or b minus a, if it's y minus z or z minus y. Like, it doesn't really matter which spot they go in. Either way, you could take the absolute value and their difference is going to be 23. So let's find those numbers. How do we find two numbers whose sum is 41 and product is 28? Usually, my preferred method is to find all the different products for 288 and just find them all and then take the sum one by one. So here's what I mean. I know that 1 times 288 is 288, but if I take the sum of that, it's 289, which obviously isn't 41. So I need to find better numbers. If I double the 1 and have 288, I get 2 times 144, which is 288, but their sum is again too big. That's 146. So looks like I need to kind of find a nice even middle number to get to around 41, or to get to exactly 41 when I add them up. So I know like 3 is probably not going to, like, 3 is, it might be, I think it is a factor of 288, but it doesn't seem useful to go through every single one. I'm trying to think. So if I add the digits of this number, I get 18. And so that's how I was able to figure out that 3 is a factor. This trick also works with 9s. So I noticed that adding up these digits gets me a multiple of 9. So I feel pretty confident to skip ahead to 9 times something is 288. I don't know that off the top of my head, so I'll just do the long division. That was going to be multiplication. Whoops. I'll just do the long division. 9 goes into 28 3 times because that's 27. And then looks like I have an 18 left over. So 9 times 32. And wow, I lucked out. That was pretty fun. 9 times 32 is 288. And then 9 plus 32 is 41. I got kind of lucky there. I have to admit. That wasn't, I didn't think about that beforehand. I just kind of lucked out and found the two numbers. So what's interesting here is that y could be 9 or 32, and z could be 32 or 9. It doesn't really matter which way you put it, because it doesn't matter which way you add or multiply numbers. It doesn't matter what comes first. Like, in comparison, it does matter when you subtract them. It does matter which one comes first. But then since we're hitting it with these absolute value bars, whether or not it's negative just kind of doesn't matter. So plugging in these numbers, I get x equals the absolute value of 9 minus 32. And honestly, I would prefer to do the subtraction the other way. Let's just flip them around. Y is now 32. Z is now 9. And then 32 minus 9, that's kind of like 32 minus 10, but not all the way. So I'm thinking about this in my head as minus 10, but then plus 1. So x is going to be equal to 23. Well, the absolute value of 23, which is just 23. So kind of lucked out here, honestly, by finding the 9 and the 32 just kind of out of nowhere. But maybe if this 41 was a little too big or a little too small, that would inform me to look maybe backwards or forwards on this factor list. But there's the answer. There's a 23, and we're all done. So I'll see you tomorrow. Thanks for coming along. Bye.